Okay, students, in this lecture, we are going to do some important numericals. They are very basic, but very important for the board exams and EAMCET examinations. Some of the twisted questions are given in the mains also. Okay, so let's start one by one question. Calculate the work done when 1 mole of water at 373 Kelvin vaporizes against a atmospheric pressure of 1 atm. Assume ideal gas behavior. It is 1 atm, not 10 atm, 1.0 atm. Okay. So let's see who will answer fastest. Okay, I am solving this question. First of all, water is evaporating. So during the evaporation, initial reactant will be water and product will be water. That is not a problem. But problem is with the gaseous state. Okay, and here we have given with 1 mole. So this will be 1 mole of H2O dissociates to give H2O gas. Okay, now at against the external pressure of, so work done is equal to minus P external into delta V. P external into delta V. Okay. So minus P external is equal to how much? 1 atm. P external is already given as 1 atm. So that won't be a problem. P external is equal to 1. So V will be V final minus V initial. So V final minus 1 into, finally you will have the water as a gaseous state and assuming ideal gas behavior. So PV is equal to nRT we can use, but because it is in gaseous state, V final will be nRT by P. Okay. So N will be 1 and R value 0.0821 and temperature is given 373 Kelvin divided by pressure is 1 atm. Okay. So by simplifying that you will get 30.6. On simplifying this, how much you will get? 30.6, okay, liter. And initially there is no gas, so it will be 0, okay. So 30.6 work done will be there, therefore it will be liter atmosphere. What will be that? 30.6 liter atmosphere, okay. So 30.6 liter atmosphere, if option happened to be in joules, what you have to do? 30.6 into 101.3. 30.6 into 101.3, then answer will be in joules. Okay, then answer will be in joules. Note down this. Okay, next question is 1 mole of an ideal gas at 2 atmosphere. See, there are a lot of twists in the question. You have to solve them very carefully. 2 mole of an ideal gas at 2 atmosphere and 27 degrees Celsius. Compressed isothermally. Ideal gas is there, isothermally is there, and compressed is there. Half volume by an external pressure of 4 atm. Find work done Q and delta U. Okay. So do it very carefully, otherwise listen to my complete detailed explanation. Okay, see, I am explaining with complete detail. 2 mole of ideal gas. So I can use ideal gas equation. PV is equal to nRT. V initial is equal to nRT by P. So V initial is equal to nRT by P. Here it is given 2 moles. So I can substitute in place of N as a 2 mole. And people are having lot of problem in selecting R value. So I am explaining here. Once volume is in liter, pressure is in atmosphere, then 0.0821. When you will take this, volume should be in liter, pressure should be in atmosphere. You can see here in this question atmosphere and liter. Okay. So we will find out the volume in liter if we use this 0.0821. If question is in 0.08314, you will take when volume is in liter, pressure are in bar. So these are the R selecting tricks I am telling you. Okay. and R value you will take it as a 8.314. When you want answer in joules, R value you will take it as a 2. When you want answer as a calories. Okay. So calories, answer, you have to check your answer. If energy is given in calorie, R value will be 2. If energy is given in joules, then 8.314. Volume you want in liter are given in liter, and pressure is in bar, 0.0831. Okay. So these are the R values. This you must have studied or you will study in the states of matter. Okay. So if you simplify this, everything I have pointed out, 2 into 0.0821 into 300 by 2. Okay. So on simplifying, you will get volume as 25.42. On simplifying this, 25.42 liter. Why this liter? Because I have taken R as a 0.0821. Okay. Now this is V initial and reduced to half volume. Therefore, V final will be 25.42 divided by 2. Now, work done will be minus P external into delta V. Here, external pressure of 4 atm. External pressure of 4 atm. Therefore, you have to write minus 4 into volume change. Volume change will be half of this. Therefore, 25.42 minus 25.42 divided by 2. But this answer will be in liter atmosphere. Okay. This answer will be in liter atmosphere. What will be on simplifying? You will get 50.84. 50.84 liter atmosphere. Okay. So to convert them into joules, 101.3. When you multiply it 101.3, then you will get in the joules. Okay. So the answer will be 5150. 5150. As it is isothermal, delta U will be 0. Isothermal process, delta U will be 0. Work done and Q already both will be same. Okay. Only sign. See, during compression, work done on the system, therefore work will be positive and Q will be negative. Q will be negative. Okay. So note down this. Okay, next question is here. Heat of combustion of methane at constant volume. At constant volume. That means it will be related to internal energy. All of you should remember constant volume means related to internal energy, and constant pressure will be related to enthalpy. Okay. Measured in bomb calorimeter at 298.2 Kelvin. Found to be this much. Find value of heated constant pressure. Heated constant pressure. Okay. Now you can try and let me check. Okay. Now I am explaining this. Listen carefully. Methane CH4 on combustion will give you CO2 and H2O. What it will give you? CO2 and H2O. Here temperature makes a vital role. At 298.2 Kelvin, water will be in liquid state and carbon CH4 is in gaseous state, oxygen is in gaseous state, CO2 also in gaseous state. Okay, carbon is 1, only you have to take this as a 1 mole because heat of combustion or enthalpy of combustion is always for 1 mole only. Okay, now here 4 hydrogens are there, this will be 2H2O. So 2 oxygens, 2 oxygen, therefore it will be 2O2. This balancing of equation is very important. And heated constant pressure. So heated constant pressure means delta H you have to find out. Okay. Given what is given, delta U is given. Delta U is equal to minus 885,389. Okay. And delta H is equal to question mark And formula we will follow is delta H is equal to delta U plus delta Ng RT. Okay. So it is minus delta U is 885,389 plus delta Ng will be product minus reactant. Don't count this because it is in liquid state. Count only this because it is in the gaseous state. 1 mole of product. Reactant, this is also gaseous state, this is also gaseous state, and 2 plus 1, 3 moles. So this will be minus 3, and R value will be 8.314 because it is an energy question. So joules are there, accordingly we will select R value. R value will be 8.314. Temperature always must be in Kelvin, and already it is given in Kelvin. So 298.2. Okay. So now you can find out on simplification. On simplification, you will get nearby 890 minus 890. Okay. 347. 347 joules per mole. Joules per mole. Okay. This is the answer. Heated constant pressure or enthalpy, all are same. Okay, next question is here. When ammonium nitrite decomposes at 373 Kelvin, enthalpy of reaction is minus 223.6 kilojoule, 223.6 kilojoule per mole. What is the internal energy change? Question, I think it is clear. Now you can try, and I will explain with detailed techniques. Okay, detailed technique solution. Okay, here ammonium nitrate. Most of the people are not able to solve when this question is given in the exam just because they don't know the formula and product. Okay, ammonium will be NH4, nitrite will be NO2. Okay, so on decomposition, that means breaking into small molecules. Okay, so the technique I am telling you to remember the formula. See, this will be one product will be N2. What will be the one product? N2. And H4 and O2 will form 2H2O. Okay. And see here, this temperature, people think that not required anywhere. But at 373 Kelvin, water will be in gaseous state. Ammonia is already in gaseous state, but this will be in solid state. Okay. Ammonium nitrite is a salt. So salt will be in solid state. And what is given, how to write the reaction, I think it is clear. Now enthalpy of reaction, delta H. One more problem is minus 223.6. It is given in kilojoules. Always it should be in joules. Therefore 10 to the power of 3, it will be joules. Okay. What is the internal energy change? So delta U is equal to question mark. Just now I have told you the problem. Delta H is equal to delta U plus delta Ng RT. Okay. So delta U you have to find out, and it is already given as minus 223.6 into 10 to the power of 3. Delta U is a question mark. Delta Ng, product minus reactant. Product here it is 2 and here it is 1. So total moles are only 3. Okay. Minus reactant is in solid state, therefore it will be 0. Now answer C. Here R value should be according to joules. R value will be 8.314 and temperature is given as 373 Kelvin. Now you can find out on simplification of this equation, you will find out delta. What you can find out? Very good. You can find out the delta U. Okay. Okay, on simplifying, I am getting 232.9. 232.9 kilojoule per mole. This is the answer. Procedure everybody must understand. Okay, next question. Heat of combustion of naphthalene at constant volume found to be minus 5133 kilojoule per mole. Okay, and you have to find out enthalpy change. So a hint I am giving you here itself. Okay, I am giving you hint here itself. You can go through this and try to solve. Naphthalene means it is simply when two benzene rings are connected together. This is C6H6. Now this will be benzene. Like this, if I combine, like this, if I combine one more benzene ring, together, then it is called as a naphthalene. Okay. So the formula of the naphthalene will be C10H8. Okay. And if I add one more benzene ring, it is called as anthracene. Okay. So, but it is not required as of now. For combustion, what we require? Oxygen. So when you heat it, then any hydrocarbon will give you CO2 and H2O. Okay, at H2O. And what you have to do, you have to balance this. Okay. Okay, here this is the naphthalene formula. How to remember this? I told you, when two benzene rings are joined together, then it is called as a naphthalene. In any type of combustion, normally what happens? Plus O2 we will write. Okay. And product will be, if it is a hydrocarbon, CO2 and H2O. Okay. Now here nothing, temperature, nothing is given, then you will take 298 Kelvin. This is very, very important. If temperature is not mentioned, you will take 298 Kelvin, room temperature. So H2O will be liquid at this temperature, and it is gas, Okay, naphthalene balls. What is that naphthalene? Naphthalene is solid or gas? Naphthalene will be solid. Okay, because naphthalene balls we put in the cloths. Okay, so now this temperature is given. Now formula, constant volume. In the question it is given as constant volume found to be. That means delta U is given minus 5133 kilojoules. Therefore 10 to the power of 3 joules. And you have to find out delta H question mark. Okay. So delta H is equal to delta U plus delta NGRT. Delta NGRT. Okay. So delta U is minus 5133 into 10 to the power of 3 plus Ng, product minus reactant. Don't count this because it is liquid. Count this is because it is gas. So 10 minus, and here it will be 12, and here it is solid, so don't count. R value, see here, joules are there, therefore R value will be 8.314. Temperature is 298 Kelvin. On simplifying, you will get the answer. Procedure, I think it is clear to all of you now. Okay, on simplifying, I am getting minus 5138 kilojoules. This is delta H value.